Welcome to the Ask Kalefi podcast, coming at you live from the lab. Guys, what do we got going on?
Plumbing, hydronics, expert insights, and a few stories from the trenches.
Whether you're on the job or just along for the ride,
We've got you covered. Hey there, welcome back to another episode of the Ask Kalefi podcast. We're back here again in the lab. Yeah, we're in the lab.
Yeah, sure.
We're not on Mars. We're definitely on Earth. Not on the moon either. Guys, what are we talking about today?
AutoFills.
AutoFills. Not Borofills?
AutoFills.
AutoFills.
Hopefully we don't Borofill everybody with this conversation. No. Autofills are pretty important component to a hydronic system, right? You got to get liquid into a system, right? Got to get fluid in there so we can heat it up. But there's do's and don'ts with these things.
Well, we got to get the water in the system and then maintain the right pressure in the system.
Exactly. And it's nice to have something with a gauge. Most of the time they have a backflow preventer of some sort on them, right?
Right.
They better.
They should.
Right.
We hope.
But there are those systems out there.
There are.
Yeah.
Yeah, that, we forgot the backflow preventer on the shelf at the shop that day. Whoopsie.
Yeah.
But yeah, there's do's and don'ts with them, right? I mean, we want to see them installed the right way. So who wants to take a kick at this one? Anybody? Because I'm tired of hearing myself talk already.
Yeah, no, they're pretty straightforward and simple. So, I mean, you pipe into your backflow preventer. This right here is an RP. So that's going to be for your high hazard applications. If you got glycol in your system, definitely want to protect it with an RP. This is going to be our dual check with atmospheric vent. Also going to maintain and protect your domestic water supply. So your domestic water supply will connect right here. That will go right into your AutoFill, which ours has a set screw on top with, you can see this little gauge up here. It comes preset at 15 PSI, and you can tweak that up or down easy enough with a flathead screwdriver.
And that was always really nice when I'd install and we'd have to bleed out
Yes.
a big system. Farmhouse, 2-story, even bigger, commercial building. You had to go around and bleed out radiators. You can set that to 25 PSI, go around, and you always have pressure to bleed out your system. And then, once everything's bled out, set it back down to 15, purge out that extra pressure that you have in the system, and away you go.
Yeah. I would say 20-some years ago, this was the very first product of Kalefi that I personally installed just out of tech school.
Same here.
Yep.
Same here.
Yep,
It was
same here.
early 2000s, and otherwise we were screwing together a Watts 9D, and threading it together with piped open thread tape, probably putting too much dope on it, and thread tape, of course, because, in hindsight. But I digress. Either way.
Yeah.
But it was nice to have something that had a gauge, no flip lever that someone would always break off.
Or how many times did you blow a relief because you left your lever up?
exactly.
You left the lever up because you had no way of telling what the gauge said unless it was on the side of the boiler.
That's when Ryan's on the second floor of that farmhouse purging the radiator, and he needed to bump that pressure up.
Just
but he
a little
can't.
bit.
He's not fast enough to get back to the basement.
Yeah, and you're halfway down and you're just hearing water rush all over the place.
Not quite fast enough.
Sorry, ma'am, I cleaned your basement floor for you.
Scrubbed it up real nice. Yeah.
Yeah, I know what's nice about ours is when it sees, that you're in that purging mode, it will increase the flow and pressure through that device to allow you to purge the system.
Yeah, you actually don't have to adjust it up to 25 PSI. It
it'll
will
start to
bump
ramp
up on its own just because it senses that there's not a lot of differential there. It's free flowing. Hey, let's open all the way.
Right.
And it will until it starts to get a little bit of back pressure.
Yeah, when you start to close that purge point, it'll see that back pressure start to build, and it will start to control and lower that pressure to where it's set to.
Yeah, it's pretty cool. The backflow preventers, I mean, obviously you called out RP and vented backflow, but there's two different ASSE standards, right? Here we go talking about ASSE once more, but that is a standard that's pretty important, right? It's the checks and balances of standards.
Yeah, absolutely.
So the double check with vent, that's going to be an ASSE 1012, and
Correct.
and then we have a 1013 over there.
1013 is the RP. So this is a testable assembly. This has to be tested on installation and annually thereafter. But I mean, this is the most foolproof, highest hazard protection that you can get out of any backflow preventer. We'll get deeper into backflow preventers on another episode coming up, but
Sure.
these are, you definitely, there's certain applications where you absolutely cannot use anything less than an RP.
Sure.
Yeah, check your municipality, check your local codes. A lot of commercial projects will require that RP.
Yep, absolutely.
And I feel the need to cover the 1012 because I mean the only time you're seeing a 1012 is on a boiler application, and the majority of the time it's gonna be tied in with an autofill valve.
Yep.
But what a lot of people don't know is these are pretty serviceable. You know, you'll get the service call, hey, there's a drip coming from the backflow preventer vent. Why is that? Well, one, it's doing its job, but what caused it? Well, it could be a number of things. You know, could be hammer in the system. You know, say maybe they went in and put in a new dishwasher or wash machine, and the solenoid in that thing acts a lot quicker. It's usually not going to happen unless kids are, or another thing is kids turning on and off faucets real fast. You know, playing around. They like to hear the pipes hammer. Not good. So
It kind of becomes an expansion device at that point.
It does.
Starts to feel that surge in pressure, and the checks will start to bounce.
Yep, they bounce and they float a little bit. Well, when you introduce water into a system through one of these fill valves to do your fill and purge initially, more than likely, if the system's tight and not leaking anything and you've got all the air out and you've done everything that you need to do to make that system work, it's done allowing water through, right?
Right.
You're not running water through. It might be 5 years before anything moves through that. And all of a sudden, we'll say we change an appliance and it's got a faster acting solenoid. It causes a hammer, or the kids are playing that one day. And all of a sudden, we get a drip after we have a hammer. Maybe we don't know we had a hammer, but hey, we see wetness on the floor in the basement. By the boiler, hey, call on a service guy. All right. So we go and we look at it and go, yep, it's doing its job. Well, why did it drip in the first place? It was the hammer. Okay. Do we need to replace it? Well, most people will just pull it out and replace it. Honestly, it's simple enough. We break the unions. Now with ours having posi stop in it, the rubber seals, you just break the unions and swap it. But if you don't have another one on your truck, all you need is to break it out of the unions. And the spot where it leaks is between the first and second check, right over the vent. And it might be just a little piece of rust. It could be a chunk of thread tape that finally made its way there. It could be a couple grains of sand.
Right.
You never know. But all you got to do is take that downstream check out right here. And if you look in there, you see a very thin line of brass, right? That's what meets up with this rubber seal. It's a pretty small sealing surface. It doesn't take much. I mean, throw a handful of salt in there, it probably will create a problem.
Right. It's going to
So
drip.
it'll make a drip. So you can pull it out, flush it with some clean water, clean all the debris off the downstream check here, and it'll probably work again for you. So I mean, you save the customer a few bucks. You charge them a service call, but you can make it work again. It's pretty easy to pull apart and clean.
Yeah, you could clean it and save a return trip if you don't have a replacement on your truck.
Yep.
Yeah, definitely.
So
It comes back to the serviceability of our products.
Mm-hmm.
I mean, that and the autofill. I mean, our autofill, it has a screen inside that'll protect the cartridge. It's easy enough to pull the cover, pull the cartridge, clean it out, put it back in service.
Right.
yeah, Matt, I think you spun one loose here, so you could even show everybody there on the camera for those who get to watch on YouTube. You can spin that cartridge apart.
Yeah, so this is not usually hand tight, obviously, but for ease of demonstration, it's as easy as taking this plastic cover off, this tension spring, which will, set the pressure that you've got dialed in on your set screw right here. Then just grabbing with the pliers on this nut up top, and this whole cartridge comes out.
And then there's a screen inside there too.
There is. So this screen will protect this seat here, but it can, depending on your water quality and how much, if if you've got a leak in your system, there's water running all the time. You can get some buildup and stuff like that. But this is completely, fully replaceable that easily.
Yeah, it's pretty nice that we're.
Greg, you had mentioned that, in some systems, especially a sealed system, it may be years since, water runs through the device. But I think, being an autofill and autofilling, I think, we did another section or another segment on air separators. There's always oxygen in your system. So as that air separator pulls that oxygen out, the autofill is going to come back in behind it and keep and maintain pressure in that system.
Right.
Yeah, which is good, but it also brings up another topic of debate. Do we leave it on in autofill mode, or do we fill the system, get everything good to go, work all the air out, and then shut it down?
My kind of rule of thumb that I tell customers when I get this kind of question is this your residence? Is this somewhere that you are every day? Where if you have a leak or a leak develops in your system, you're going to notice water running all the time trying to refill that. If the answer is yes, I would leave it open. I would leave it on and just maintaining that pressure. If this is, a vacation home or somewhere that you visit every couple of months or something like that, and you're nervous about not being there and a leak developing, I would recommend closing that.
It's solid advice. Yeah.
Yeah. I would ask him, like, kind of like you, Matt, what's your habits? Are you here all the time? Are you not? I would sometimes lead to closing it, because if there is a problem and we got a leak, at least we know we have a leak. If it's a older system, you close it, and all of a sudden next year you're down on pressure. Well, hold on, time out. We got a problem somewhere.
Right.
Yeah, it's that age-old debate. Do you do it? Do you not do
We
it?
did an episode on that years ago.
We might have, and I'm agreeing with that. If it's an older change-out job where you got a lot of old iron pipe and cast iron rads, and then hey, there's an addition put on in the 70s, and that's all baseboard, and you get a lot of mixture of different connection types. And I would, if it were mine, I think I'd want to pressurize it up, get all the air worked out of it, do my flush, get my pressure where I need it to be, and then I would close it off, because then immediately, if there is a problem, the boiler is going to go, hey, low on pressure, if it's a smart enough boiler to do so, right? And that bat phone's going off, isn't it?
Oh, might be a tech call.
It could be.
Bring
Could be
them
a tech call.
You're live.
You're
We're
live.
live on the Ask Coffee
Yeah,
podcast.
good stuff. Yeah, with all that kind of extra connections going on, I would want to know if my system were leaking, and if it means that the boiler is going to shut down because, hey, there's something going on, I would rather have that than have that thing just replenishing, pumping more oxygen in there, creating more breakdown in the system, and just water leaks. It makes a mess.
Yeah.
Mold damage, water damage is not a fun thing to deal with.
Especially, if, like you said, if you've got decades old system with in-floor, you can have a leak and not note it.
Right. Never.
Right.
Right.
Yep. Yeah, I had a system.
Systems with old copper in floor where that copper pipe
In
would
the
start to
concrete.
leak under the concrete.
Yeah, I busted up a lot of concrete in the day.
I've told this story plenty of times, but when I first started working in the industry years ago, we had a Frank Lloyd Wright house down in Fort Atkinson with in-floor, built in the 20s. And guess what they used for tubing?
Copper.
No.
Oh.
Steel.
Oh.
yeah.
They used steel.
Yeah.
And it made it a long time before, hey, we notice our water bill is really high. And of course, mechanical rooms in those houses were very tight and everything's very wide open. It's slab on grade, essentially. Yeah. And then you had like a loft. It was multi-level. It was pretty neat looking home and very intricate finishing. But everything was in floor in the concrete floors. So, okay, it's using a lot of water, and the boiler was an old Burnham cast iron fired up, and it kettled like crazy. It thump, ka-thump, ka-thump as it got hot. It's like, okay, there's a lot of lime and debris in the bottom of this thing. It's not real good. All the manifolds came up from behind the boiler, and we had about this much room. Well, guess what we're doing? We're cutting the boiler out, and we're going to move it out of the way, and we pressurized the 3 different zones. It's 3 zones. First one failed within 20 seconds. Like as fast as we were pumping air into that sucker, it was going out.
Right.
The other one, we were aired up to like, I think we put 20 PSI on it, and it lost all 20 within 2 minutes. All right, that's no good. And the third one held. I'm going, no, I want to hook that one up. That's under my master bedroom. I'm like, okay, we'll see you next year. And we did.
Yeah.
So what was the fix for that? Well, we ended up actually putting in baseboard.
Sure.
We ended up putting in baseboard and exposing all the pipe, and it didn't look real pretty. The guy paid big money for a finish carpenter to come in and put all this nice oak trim around it and trim it all out so you never saw it. But then we had all these baseboards underneath all the windows, and it was a big job to do all that. But the autofill, you know, if the autofill would have been shut off, he would have known, hey, there was a problem. But instead, that thing was just constantly running, and dumping water. And I bet he spent thousands of dollars, and who knows when that system actually broke loose and started.
A lot of air brought back in.
Oh, tons of air.
Yeah.
And of course, it had an air scoop on it.
Of course.
You know, that comes back to if you keep introducing new water, if you treated the water and you do get a leak, now you just, all the water that you treated,
Flushed it right out.
it's all gone.
Right.
Yep.
So
Yeah, it's a valid point.
I guess another thing to bring up too about our PRV on there is our knob on the bottom. Mm-hmm. A lot of questions about that.
A lot of questions.
Yep.
A lot of questions
Yep.
about that. And basically, that's just a service valve.
Yeah, it's an isolation
It's
shut
an
off.
isolation shut off.
And what I tell guys to do is, if you wanted to run an automatic fill mode all the way down until it stops, you backseat the valve. If you want to shut it off, I mean, everybody goes, well, we got a ball valve. Yeah, you got a ball valve. You could use a ball valve, or you could use this too.
Right.
But if nothing else in service mode, when you're trying to get this cartridge out of there, you can actually use it to help push that cartridge up if it feels like it's a little stuck and you can't quite get it out.
Right.
You front seat it all the way to the closed position, and it'll push that cartridge up.
Yeah, because I get a lot of calls of the plus and minus
Yep.
on the bottom.
Yep.
And they're
And
always
it-
thinking
It's the opposite of what it actually seems.
Right.
And it's a little confusing.
Well, and like Greg, like you mentioned, the key is all the way open or all the way closed.
Yeah.
Right.
If
no
you're
in the
somewhere
middle.
in between, you can actually interrupt the operation of that cartridge and affect the performance of the unit.
And get a little harmonics out of it. I think
Yeah.
we had one earlier, probably a couple months ago, that had that.
Yep. Yeah, if you don't front or back seat it fully, that cartridge can't close off all the way, and it'll essentially overshoot its pressure. Speaking of overpressurizing, I think we need to cover point of no pressure change and like location of the fill. Usually when you're locating a fill, it's with the expansion tank, right?
Yeah, typically.
Typically, not always, but there's majority of the jobs that we've done, it's right with it. It's
Yeah.
teed in together.
Yep, the two will come in
So,
together.
I mean, who wants to take a kick at point of no pressure change? Anybody? Bueller?
I can do that.
Yeah,
I mean-
I'll help you.
Basically, the point of no pressure change is the lowest pressure point in the system, so just upstream of like the inlet side of your circulator.
Yep. Agreed.
And that's the best point for your autofill. That's where you're going to set that pressure that you want to maintain
Yeah,
in
it's
that system.
the best point for the expansion tank and the autofill. I mean, you don't want your autofill on the downstream side of the pump, because now you're pumping into that, you're preloading that expansion tank.
Kind of like our last podcast. Good spot for the air separator as well.
Yep.
Yeah.
You know, and that's why guys typically will pipe air separator in and then expansion tank, fill line, all right there off of the bottom.
Sure. And I'm going to muddy the water a little more.
Oh,
Here we go. Supplier return side, should we put it on?
I was always told supply.
I mean, if you're putting it into an air separator, ideally your air separator is
Yeah.
on your supply
If,
side.
if you're bottom of the air separator, you'll
Yep.
be on the supply.
Yeah.
But we do see them on the returns.
Yeah, I mean, I got into the habit of putting it on the return
Yeah.
because if you're pumping, and this is where it gets muddy, right? Because you look at a piping diagram and you go, well, the pump's right there on the supply side. It's pushing water right at the air separator. Is that good or bad? Well, it's good, fine for the air separator, not so good for for the expansion tank.
Sure.
So, okay, what if we put the pump on the downstream side of the air separator? As long as it's far enough away, it shouldn't create any problems, right? With drawing the float down and ingressing more air. And you're not preloading the diaphragm in that expansion tank. Okay, cool. But what if I put it on the return? You can do that, sure. Well, and if the pump is still up in the supply side, you got to remember there's going to be losses, right?
Yeah.
There's a loss through that system,
Yeah.
going through all the inflow, all the radiators, heat
Friction
emitters.
loss through that whole
And
system.
Exactly. So once you get back to the return side, you're still on the, the positive side of the pump. Not really, because by the time it gets there, we're kind of almost down to zero.
Right.
Yeah.
We're down to zero pressure.
Yeah, I
And-
mean, if you've got a real short trip back up to that circulator from there, I mean, you essentially are almost on the upstream.
Yeah.
Right.
Yep. So you're usually in pretty good shape. But the whole point is point of no pressure change for that expansion tank. The fill, everything lives longer in cooler water, right?
Right.
So if the chances of really hot, we'll say 180 degree water, we'll say it's a hot water system, of getting down out of that air separator through the fill and to the expansion or to the expansion tank at all, slim to none, because you actually need water flow to get that heat there.
Right.
So you could grab hold of the top of that tank and it won't be hot, even though you got 180 degree water running 6 inches above it.
Correct.
It'll be fine as long as you don't have water flow there. If you do have water flow there, then we know we have a compromised bladder, right?
Right.
So something else is going on. I think we covered that one pretty well.
I think so.
Yeah,
Dove deep right into it.
we did.
Yeah.
Ears deep, right? Mm-hmm. Just like the dog.
Well, it's like we always say at the end of any podcast, we're always here to support you. If you have an autofill or a backflow and it's doing you something you think it shouldn't be, or you need help picking a product for that applications, that's what we're here for. Give us a call.
Yeah.
Absolutely.
Thanks everybody for tuning in. Catch you on the next one.
See you later.
Bye, everybody.
Well, that's a wrap for this episode. Got questions or stories to share? We'd love to hear from you. Reach out and let's keep this conversation going.
Don't forget to subscribe and leave a review wherever you listen.
Until next time, stay curious and keep your systems running smoothly.